Hi, my name is Imtiaz binti Izani from class 8127 4A.
Hi, my name is Nurul Sabina binti Ahmad Syafi from 8127 4A.
Hi, my name is Emily Adriana binti Saini from class 8127 4A.
Feed Conversion Ratio, or FCR, is an important measure in aquaculture that shows how efficiently fish convert feed into body weight. A lower FCR means better efficiency and sustainability. However, achieving a good FCR is difficult during the early life stages of fish, where feeding directly affects their growth and survival. Microworms, or known as Panagrellis redivivus, are a suitable live feed for larvae due to their small size, slow movement, and high nutritional value. Therefore, these studies evaluate the FCR of guppy fry, Poecilla reticulata, when fed with microworms to determine their effectiveness as a starter feed. The problem statement for this study is that larval rearing in aquaculture heavily relies on feeds such as artemia and commercial powders. These feeds are widely used because they are effective, but they are also expensive and mostly imported. As a result, the high dependence increases production costs and make it difficult for small-scale farmers to afford consistent feedings. This situation highlights the need to explore more affordable and sustainable alternative feeds for larval fish culture.
Now, I'm going to talk about research objectives. First, to evaluate the feed conversion ratio of a guppy fry fed with microworms. Second, to analyze the growth performance of a fish when fed with microworms. Third, and lastly, to compare the efficiency of microworms as feed based on FCR and growth result. Next, I'm going to talk about hypotheses, which we have two. First is null hypothesis, which is H0. Second, we have alternative hypothesis, which is H1. For the null hypothesis, is feeding guppy fry with microworms have no significant effect on feed conversion ratio and growth performance. And for alternative hypothesis, feeding guppy fry with microworms significantly improve feed conversion ratio and growth performance, resulting in more efficient feed utilization. Next is our research question. How does feed guppy fry with microworms affect feed conversion ratio and growth performance in aquaculture?
This research is important because it focuses on feed conversion ratio, or FCR, of guppy fry fed with microworms. FCR helps us to understand how efficient the feed is in supporting fish growth. Through this study, we want to see whether microworms can be an effective starter live feed for larval fish. The results can help fish farmers find a more cost-effective feeding options, which may reduce production costs. In the long term, this study also supports more sustainable aquaculture practices by improving feed efficiency, fish growth, and survival, while contributing to food security.
To begin our literature review, we must look at the global state of aquaculture. Currently, aquaculture is recognized as the fastest growing food production sector in the world. However, its growth is heavily dependent on fish meal, which is becoming increasingly cost and raises significant environmental concerns. Secondly, statistics show that about 1/3 of all white-caught fish are diverted to produce feed for farm fish. This highlights an urgent need for more sustainable and circular feed alternative. By moving away from wild-caught fish meal, we can reduce the pressure on marine ecosystem and improve the long-term sustainability of the industry. Moving into the next slide, microworms Panagrellis redivivus as a live feed. Microworms are classified as small nematodes, making them the perfect size for the first feeding larvae of many ornamental and food fish. They are rich in protein and lipids, providing the energy needed for rapid early growth. Microworms offer a significant advantage because they can be mass-produced easily using simple and accessible material such as oatmeal and oatmeal oils. This makes them a much cheaper and more sustainable option compared to artemia, which requires expensive seeds and complex hatching setups. Lastly, studies have shown that larvae such as blue swimming crab can start feeding on microworms as early as 2 days after hatching, which often leads to better survival rates compared to inert diets. This broad success across different species gives us high confidence in potential of microworms to improve growth and FCR of guppy fry in our study. Moving further into the impact on feed conversion ratio, worm-based proteins such as Acinia fetida are known to be highly digestible and significantly improve the amino acid profile of the fish. According to research by L. Uni et al. 2023, this specialized protein source is crucial for healthy development. Furthermore, research indicates that replacing approximately 20 to 20% of traditional fish meal with worm meal can improve overall feeding efficiency. These substitutions help lower the FCR, leading to better performance and increases the efficiency of protein use within the fish bodies. Live microworms stay viable in the water column, preventing rapid water quality deterioration and nutrient loss. Finally, as highlighted by Ellison et al. 2015, aquatic worm can convert organic waste into high-quality protein. This creates a sustainable circular feeding system that reduces waste while providing top-tier nutrition for our guppy fry.
Now, looking at the strength, microworms are effective as biological bridge during early larval stages, meaning they help fish transition from yolk absorption to external feeding. They also have a lower risk of introducing pathogens compared to wild-caught live feeds. However, there are some limitations. Most studies focus more on survival and growth rather than accurately measuring feed conversion ratio, especially in tropical fish species. This creates what is known as the FCR gaps. In addition, microworms lack essential fatty acid, so they often require enrichment to improve their nutritional value. There are also some inconsistencies. For example, growth performance may decline when microworms replace more than 25% of the diet, possibly due to palatability issues and amino acid imbalance. Furthermore, their nutritional value can vary depending on the culture medium, which leads to less consistent experimental results. The gap in the study is that although feeds like soybean meal and earthworm meal have been widely researched, there are still limited studies that directly compare the feed conversion ratio of live microworms with commercial starter powders in a controlled environment. Therefore, this study aims to fill that gap by comparing the FCR of microworms and commercial starter feed in guppy fry, Poecilla reticulata. This research is also supported by previous studies such as Effendi et al. On larval feed acceptance and L. Oini et al. On feed utilizations, with the aim of developing a more practical and standardized feeding methods for fish farmers.
Now, I'm gonna talk about methodology in experimental design and setup. First is a research design, which is comparative experimental study. Second, study size and species, conducted in a controlled laboratory hatchery. The species we're gonna use is a guppy fry, which is Poecilla reticulata. Guppies are chosen because they are live barrier, which is born active. They have a high metabolic rate and their fry are the perfect size to consume microworms immediately after birth. Third are materials and treatment. For our materials, we're gonna use commercial starter powder, which is standard micropellet. For our treatment, we're gonna use live microworms, which is Panagrilus redivivus, culture on an oatmeal, and 4 is procedures. For randomization, 6 tank filled with 10 fry per tank with 3 replicates for each treatment to ensure statistically accuracy. For feeding, we need to feed them twice daily at a fixed ration of 5% of body weight. For maintenance, daily 20% water exchange to prevent ammonia buildup for uneaten powder in a control group.
The next slide, data collection and metrics. Sampling frequency data is collected every 7 days over 21-day period. Weight measurement, guppy fry are weighed using a digital analytical balance 0.001 gram to determine weight gain. Our primary data point for this study is the feed conversion ratio. We use this metric to compare the efficiency of microworms against commercial powder. The FCR is calculated using the standard aquaculture formula, total feed consumed in grams divided by the weight gain in grams. Lastly, we monitor the survival rate through daily counting. This is calculated as the final count divided by initial count multiplied by 100. By combining FCR data with survival percentage, we can provide a comprehensive evaluation of microworms as a sustainable and effective starter feed. To conclude our methodology, we will look at the data analysis and ethical standards of our study. To fulfill the requirements of CL01, we have selected the independent sample t-test as our primary statistical tool. We choose this specific test because it's designed to determine if there is a significant difference between the means of two independent groups. In our case, it will allow us to compare the growth performance of the microworm group against the commercial powder group. Lastly, ethical considerations. We are committed to high standards of animal welfare. During the experiment, all guppy fry will be handled using a wet hand and soft net technique. This is crucial to avoid damaging their sensitive and protective mucous layer. To ensure stress reduction, the weighing process will be conducted as quickly as possible, and the fry will be returned to oxygenated water immediately. Finally, our study is highly practical. It is designed to be completed within the semester timeline and uses low-cost, sustainable materials that are readily available in our laboratory. This makes our research not only scientifically sound but also highly feasible for implementation.